All right, so here we have a polar covalent. Polar is when it's not even sharing. Covalent means that there is sharing. Covalent bond in which the bonding electrons are not shared equally by the bonded atoms. This results in electrons spending more time around certain atoms in the molecule, and this causes a slight difference in the charge throughout the molecule. All right, so for this one, we're going to have a slight positive and slight negative region to the atom. Okay, so the electrons spend more time around the atom with the higher electronegativity. Polar molecules have an electronegativity difference of 0.4 to 1.9, and I got this from some AP Chem information, because they seem to fluctuate the numbers every once in a while, but for right now it's 1.9. All right, let's do our example. So chlorine, how many valence electrons does chlorine have? 7. And then how many does hydrogen have? All right, we're going to bond these together. So we're going to have chlorines with its 7, 1 dot here, hydrogen with its 1 dot there. We're going to bond them together. All right. Hydrogen's number is 2.1, right? On that periodic table. All right, so its electronegativity is 2.1. Chlorine is what? 3 point something? 3.0. Okay. And then what's the difference between these two? Yeah, it's going to be 0.9. Which one's stronger, chlorine or hydrogen? So I draw the arrow towards the chlorine, okay? And in this case, it's going towards the chlorine, and it's 0.9, okay? So this is tug of war, two people that are different sizes, all right? More energy, pulls greater. We go 0.9 in this direction. Now we're between this, so that means it is going to become polar, all right? Now, what are the charges going to be? Which one of these two is going to be the more negative one? Which one's going to be the more positive one? Chlorine's going to be negative. Yeah, exactly, because electronegativity means pulling electrons towards it. So we're going to give it this symbol here, lowercase delta. And then we have negative for the chlorine side, positive for the hydrogen side. All right? And this would be a polar molecule. Any questions with that? What if we had another one of these? Another Cl and H molecule, and I want to draw it right here. Which side of it's going to be attracted to the H plus? Cl, because it's negative, right? So we're going to have Cl, H. This side's going to be slightly positive. This side's going to be slightly negative, all right? They're going to be attracted to each other. A way to show that is with a dotted line here, because it's a bond, but it's a really, really weak bond, all right? Doesn't last very long. Does anybody know what kind of bond this is? The dot should go from the H to Cl. Yeah, Brian.
Hydrogen.
It's a hydrogen bond. Yeah, exactly. It's a hydrogen bond because you have a slightly positive hydrogen here, slightly negative other atom here. They're attracted to each other. You get a hydrogen bond. It only lasts for like a split second, but it happens again and again and again very quickly, so that holds things together. All right. And this is when you have a polar molecule, it's usually connected because of a hydrogen bond. All right. Any questions with that? No. All right. Cool. All right. So to show that a molecule is polar, we use the lowercase delta, which is a Greek symbol. This is what it looks like. Like I was drawing it kind of like similar. And these show what's called the dipoles. So the dipoles are the positive and the negative parts of the atom, the poles of the atom. All right. And when it says show dipole interaction, that's what we did for this one. This is the negative pole. This is the positive pole. This is dipole interaction where you have the dotted line. They're attracted to each other. All right. So all polar molecules will get that kind of like hydrogen bond like attraction. All right.